in this particular video we're going to be looking at the AQA specification for foundation paper, and it's the paper 2. Now if you want to follow the link below in the description to be able to print this particular paper off, have a go at each of the questions and see how you get on. Keep stopping and starting the video. I'm going to aim for this particular video to be about 20 to 30 minutes in length, and we're going to work through the whole paper in probably about the next 3 or 4 videos. Okay, hope that's all right for you. Let's move on then with question number 1. And question number 1 says, which of these numbers is 1 more than a multiple of 5? Well, you've got to imagine your 5 times table really. So you've got 15, well that is in the 5 times table. You've got 19, which isn't. And it's not 1 more. You've got 26. Well, that actually is 1 more than 25. So 25 is in the 5 times table, and this is 1 more. So I'd say 26 is the answer to that question. And then it says in question number 2, which of these has exactly 3 factors? Well, you need to know these definitions really. So factors are numbers that will divide exactly into the number. So with 3, for instance, I've got 2 factors, one of which is 1 and one of which is 3. With 4, I've got 1, 2 and 4. With 5, I've got 1 and 5, and with 6, I've got 1, 2, 3 and 6. So the number that has exactly 3 factors is actually number 4. So I put a circle around that one. Okay, and then question number 3 is just a little bit of arithmetic. Which of these numbers is 6 less than minus 1.4? So what we mean by that, if you can imagine a temperature, if that's 0 and that's minus 1.4, and then it's actually going to get 6 degrees colder. So it's going to go down 6 jumps and it's going to come down to minus 7.4. So actually the number which is 6 less than minus 1.4 is minus 7.4. Do be careful about those sorts of questions. Although they're only 1 mark, they will make quite a difference with your end grade. Please do always make sure you check those questions. Okay, so let's move on then to question number 4. And question number 4 introduces this concept of congruency. Okay, so congruency is a mathematical word that they tend to like, and basically all they mean is which shape is the same as shape X. Okay, well, it's one of those situations where really you just need to be able to see it and work your way through how these shapes will look. There isn't any easy way of kind of showing you this other than to suggest that if you print this off, you'll be able to see that this shape is actually a rotation of shape D. It's exactly the same, but it's just been rotated from here, and it's sort of almost gone 90 degrees, well, has gone 90 degrees in the anti-clockwise direction, and it looks like that. So actually the shape which is the same or congruent is shape number D, shape letter D. Okay, so let's move on then to question number 5. These kind of questions are becoming kind of popular with these sorts of level of exams. So map shows positions of 2 ships, and the whole idea is that you've got 1 centimetre representing 2.5 kilometres. So you need to be able to measure the distance between A and B and then multiply that by 2.5, and that will give you the actual distance. So if I measure across here, that's going to be 8.5. Hopefully you can see that. It's close enough to 8.5. I actually now make it about 8.2, 8.4, something like that. But it's close enough. It's going to be 8. Let's call it 5, because that's actually what I've done my calculation on. I'm going to multiply that by 2.5. Now this is a calculator question, so if you work that out, it's going to give you 21.25, and actually as this particular answer is 21.25, the answers in the mark scheme are anywhere between 20 and 22 Okay, so that's perfectly fine. All right, hope that's okay for you. Let's move on then to question number 6. So in question number 6, we're talking about percentages. Now, percentages are something, again, that you need to kind of get used to dealing with. They do come up quite a lot in these exams. So it says a gym has 275 members and 40% of them are bronze, 28% are silver. Well, it's like we've done before with word questions. What I normally do is try to sort of encourage you not to worry about the rest of the question, just worry about the bit of information they've given us. Well, the question would be is why have they told us 40% are bronze? It's because they need us to calculate that little bit in order to be able to answer the rest of the question. So I'm going to go kind of right ahead and just calculate that basically for bronze we're looking at 40% of 275. Now, I'm very aware there are ways in which people do these sorts of calculations. What you could do is you could take 10%, which is 27.5, and then multiply that by 4. Well, actually, that's what I'll do. I'm going to multiply 27.5 times 4. Now, when I'm multiplying by decimal, I don't put the decimal point in right at the very beginning. I put it in right at the very end. So if I work that out, I get 1100, and then I put the decimal point in. So actually, there are 110 bronze members. Okay. Let's look then at silver members. So now 28% of them are silver. So what I have to do is I have to work out the 28% of 275. Okay, well, again, very similar thing you could do. You could work out 10%, you could work out 1%, multiply that by 8. You could do all sorts of things with this. What I'm going to do is I'm going to actually do it as long multiplication. Okay, now if I do it as long multiplication, again, I have my method of doing this. You might not agree with this. It might not be something that you actually do, and that's perfectly fine if you partition it or you try something different. However, the way I would calculate that is I would look at just 275 times 28, and then I would put my decimal point in afterwards, because don't forget that this is actually 0.28. Because you need to be multiplying by decimals. So I would then say that's 77, so it's actually 77 members are bronze. Okay, now in terms of the calculations, do make your calculations clear. They do allow 3 marks for this particular question, so if you do make a slight error on the calculation, you at least will accrue some marks. And do try to put your calculations in such a place that the examiner will be able to work out how you've understood the question, what it is you're doing. Now, unfortunately, they've not given us a huge amount of room on this particular piece of paper, so what I'm going to do to find out the number of gold members is I'm going to add these two together, and then I'm going to take that away from 275. So for gold, if I just write this down here, it's going to be beg your pardon, it's going to be 110 plus 77. Okay, so that's my first bit of calculation, which gives me 187. And then to actually work out the members, it's going to be 275 minus 187. And if I work that out, I'm going to come out with 88. Okay, so in this particular case, the number of gold members will be 88. Okay, hope that's all right for you. I am aware this is a calculator question. However, I think sometimes it's well worthwhile showing your working so that the examiner will really understand what it is you're doing in order to answer that particular question. Okay, so let's move on then to question number 7. And question number 7, we've got one of these number machines and number problems. So he's looking at a number machine. Okay, so what he's saying is that if he puts a number in, let's call it 7. So he's going to put 7 in here. He's going to add 3 to it, which would make 10. Then he's going to take 5 away, and that's going to make 5. So in other words, the output of this machine, if you put 7 in, will give you an output of 5. Okay. And then it says if I know y, I can work out x because I can subtract 3 and then add 5. And does this method work? Well, in this particular case, yes, it does. Now, I think it's a bit of a tricky one to really answer, but what we're saying is that the add 5 and the add 3 and the minus 5 actually perform the same thing. It doesn't really matter which order in which you have them. So the answer is yes, okay, because the order doesn't matter. Okay, and with addition and subtraction, that's perfectly true. Okay, and what you could do if you wanted to is you could just try a few numbers and see if you can kind of work that out for yourself. Just make sure you satisfy yourself that that's true. Okay, so part B then is slightly different way because in this particular case the order definitely does matter. Okay, because he's put, if I know D, I can work out C, because if I divide by 3 and then subtract 5, the method won't work. Okay, in this particular case, you need to make sure that you maintain the answers. So in this particular case, what you need to do is subtract 5 first and then divide by 3 afterwards in order to work out the value of C. Okay, so in this particular case, the method doesn't work, so no, because the order matters. Okay, and again, you might, just for the sake of completeness, you might want to add a couple of examples just to show the examiner that you understand what it is they're asking you to do. Okay, so let's move on then to question number 8. And question number 8, we're dealing with some algebra equation, and it says it wants you to find out the value of w. So solve 5w minus 11 equals 24. Okay, well again, there are a couple of different methods. The favoured method with this is to say, well, I need to get w's on one side, or at least initially at least 5w on one side, and then this minus 11 needs to go over to here. So if I do that, the way I'm going to do it is I'm going to add 11 to both sides. If I add 11 to both sides, that and that disappears. And on the left-hand side, I get 5w. On the right-hand side, I get 24 plus 11, which is 35. So what we're saying then is 5 lots of w equal 35. So if I divide by 5, that's going to give me 1 lot of w. But I need to divide by 5 both sides. So 35 divided by 5 is going to equal to 7. So w equals 7. Okay, hope that's all right for you. Let's move on then to question number 8b. And it says, write an expression for the total cost in pounds of some jumpers and some shirts. Okay, the jumpers cost 15 quid and the shirts cost £12 each. All right, well, the way you would work that out is if you can imagine if you're going out and you're buying these things, you're going to, let's say you're going to buy 5 jumpers. Okay, well, they're going to cost you £15 each. So what you would do is you'd multiply 5 times 15. Well, we don't know how many you've bought, so I'm going to say it's 15 times x. Okay, that's how we would write that. And it's the same again with the shirts. Let's say you're going to buy 3 of them, so 12 times 3 would be £36. Okay, however, we don't know how many you're going to buy, so we're just going to buy Y number of them. So it's going to be £12 times however many you buy. And that's actually the answer to the question. Now, it's good if you actually have a subject, which is the amount it's going to cost you. Okay, so the total amount of pounds is equal to 15 times the number of jumpers plus 12 times the number of shirts. Okay, so in answer to a particular question, you'd write something like T equals 15x plus 12y, and you can put a pound there if you want to. Okay, hope that's all right. Let's move on then to question number 8c. Now, question number 8c, we're being asked to simplify. So, really, if you look at this, we've got x plus x. Well, that's going to give us 2x. Okay, 2 lots of x. And then you're going to add that to y times y. So they've been a bit sneaky with that one, because y times y is y squared. Okay, so just be very careful about this. And again, as we've mentioned before, do please check these particular 1 mark questions. With the AQA paper, they tend to like these 1 mark questions right at the very beginning, so it's well worthwhile having a go at them to get as many marks as you possibly can. Okay, so let's move on then to question number 9. And it's one of these statement type questions. Lucy says that 3 is odd and 2 is even. So if you add a multiple of 3 to a multiple of 2, the answer is always odd. Is she correct? All right. Well, let's try. And generally speaking, for these types of questions, they are only 1 mark. There really isn't any shortcuts, but it's much easier just to simply try it and see what happens. Okay, so I'm going to do multiple of 3. And I'm going to do a column for that, and I'm going to add that to a multiple of 2, and I'm going to see what happens. Okay, so multiple of 3, let's say I've got 6, that's in the 3 times table, is a multiple of 3, and I'm going to add that to a multiple of 2, let's say 4. Well, that's going to give me 10. Okay, so in this particular case, when you add a multiple of 3 to a multiple of 2, the answer is always odd. Well, she's not correct, because that's actually even. So let's just check if we can make it an odd number, just to make sure that it's either going to be odd or even. So a multiple of 3 is, say, 15, plus a multiple of 2, let's say 4 again. Well, that's going to be 19. So actually, in this particular case, she is incorrect. Okay, she's incorrect. And the reason she's incorrect is because it could either be odd or even answer. Okay, good stuff. All right, let's move on then to question number 10. And Tom earns £9.20 per hour. Okay, a little bit more than me actually. He works for 24 hours each week and 48 weeks each year. He pays tax if he earns more than 10,000 per year. Does Tom pay tax? Okay, so let's have a look at what his weekly earnings are going to be. Firstly, because that's the information that they've given us. So 24 hours each week at £9.20. So you need to use your calculator, but his weekly pay is going to be £9.20 times 24, and that's going to give you £220.80p. Okay, so that's how much he's going to earn in a week. Okay, then if he works for 48 weeks per year, so yearly, that's going to be 48 times 220.80, so that's going to give you a total of £10,598.40. Okay, so unfortunately for Tom, he's going to have to pay tax because he's above the threshold of 10,000. So in this case, yes, Tom pays tax. Okay. All right, so let's move on then to question number 11. I'm very aware of the time now, so we're coming up to about 20 minutes, so I'm going to keep going. I hope this pace is okay for you. I do appreciate that there's a lot to get through in a typical video, so hopefully you've had the opportunity to keep stopping and starting the video to have a go at each of these questions. Please, as I've said before, I keep saying it, please don't passively just watch the video. Please make sure you stop and you have a go at each of the questions before you view the solutions. Okay, so 3 boxes contain counters, 62 counters in total. So what we're basically saying is that, according to them, A plus B plus C is going to equal to 62 counters in total. So we need to bear that in mind, okay? Then it says the total number of counters in box A and box B is 34. So if there's 34 between A and B, that's fine. And then it says the difference between the number of counters in box A and box C is 9. Well, let's just hang on out for a minute. Let's just have a look at that one there. Okay, so we've said that if there's 62 counters altogether and 34 are in A and B, then the box C must contain the difference. So if I work out 62 minus 34, that's going to give me 28. So it must be in box C there are 28 counters. Okay, now if that is the case, we can then work out the next bit. So it says the difference between the number of counters in box A and box C is 9. So if I take 9 away from 28, it means that in box A I'm going to have 19 counters. Okay, well that's great. And then I need to work out the difference between 34 and 19, which is actually 15. So it must be that in box B there's 15 counters. Okay, now if I total all of those up just to check, that 19 add 15 add 28 equals 62, and that's perfectly fine, so it answers the question. These kind of questions do crop up, so it's well worthwhile practicing them. Unfortunately, it is quite difficult to practice. You just need to do as many of them as you can, really, just to find out how to kind of logically think through these ones. They're, in a sense, they're a bit similar to Venn diagrams. If you've done some Venn diagram work, it's a very similar sort of logical kind of process. Okay, let's move on then to question number 12. So in question number 12, we've got the good old standby of a pie chart. Okay, you're going to see pie charts such a lot. They do keep cropping up. They're really very, very popular. So the pie chart shows information about sales of 800 tickets. So what we're saying is that overall, this whole pie chart represents 800 tickets, of which some are being bought by children, some are being bought by seniors, and some are being bought by adults. And what we're being asked to do is to show that there were 140 senior ticket sales. So in other words, what we're saying is that this chart, this sector as it's called, represents 140 tickets. Okay, so just be careful about that. That's what they're asking us to do, is to show that. Okay, well really the easiest way is to kind of work out the amount of degrees per ticket, because effectively if we've got 800 tickets across the whole thing, we know that in a circle there are 360 degrees. So if I work out 800 divided by 360, what that means is that it's 2.2 recurring. This is 2.2222 so on per ticket. Okay, so every ticket on this particular pie chart is represented by 2.222 so on degrees. Okay. Then I've also got this situation here where I've got 171 degrees for children, seniors for a portion of it, and then adults for a portion of it. And it tells me there's twice as many adult tickets as senior ticket sales. So in other words, what we're saying is that out of the remaining degrees, which is actually 189 degrees, that's in total 189 degrees, because this whole circle adds up to 360. What I've actually got is 2 lots of adults and 1 lot of seniors. Okay, I hope that's clear for you. So what we're saying is that, I'll just cover that again. So this is 189 degrees because this whole circle is 360, and we know this is 171. We also know there's twice as many adults as there are seniors. That's what it says, twice as many adults as there are seniors. So there must be 3 equal portions, if you like, out of that 189 degrees. So if I work out how many degrees there is in each of these portions, it's 63. So what we're saying is that this senior is 63 degrees, and 63 degrees represents 140 tickets. Well, in order for us to show that, what we would have to do is say, well, each of those 63 degrees if I then multiply by 2.2 degrees per ticket, it will tell me how many tickets there are in the seniors. So I'm going to do that. I'm going to say 63 times 2.2 per ticket. Okay, that's going to equal 140. So what we're showing is that there is 140 tickets represented in the senior ticket sales. Okay, I'm very aware I think that's quite a tricky one. It is quite difficult to kind of get your head around, but really with pie charts, try to find a way, if you can, to get this bit of information. Once you've got this bit of information, then hopefully you'll be able to kind of work through the problem to be able to come up with a solution that works for that particular question. Okay, so in this particular one, I've got 12b, which I'm going to cover just very briefly, because it does ask you to draw a bar chart on a grid to represent the child, adult and senior ticket sales. So you haven't kind of wasted your time really just by doing all those calculations on part A, because what they're after you doing is kind of putting into this bar chart the senior, okay, which we've calculated as being 140 tickets, the adult and the child. Okay, now I am doing this on a video, so it's probably going to be a little bit of a wobbly drawing, but we'll give it a go. Now, just as a bit of a tip here, we know that there are 800 tickets altogether, but we also know that if we go back to the bar chart, we've got 140 tickets for seniors. Okay, now 2 lots of them are going to be for adults, so for adults this is senior. Okay, for adult, well, it's going to be double that, which is going to be 280, and then for child it's going to be the remaining amount. So there's 800, take away 140, take away 280, and that's going to be, I'm having to work this out as I do it, so I'll just do that over here. So that's going to be 800 minus 140, which is going to be 660, and minus 280, so that's going to be 5180, and that's 380. Is that right? So that's going to be 380. I hope I'm okay with that. I'm just going to check that I've done that correctly. So if I make that 380, okay, add up all of those, so that's 0, 16, 20, 2 to carry, 3, 4, 5, 6, 7, 8. Brilliant. Okay, so in other words, on my bar chart, I have to represent 280 for the adults and 380 for the children. Okay, so let's go back to the bar chart and let's create that. Okay, so if I look at that now, if I look at the left-hand side, what I can see is actually there's blocks that sort of naturally lend themselves to 100, and then I've got here is going to be 200, and here is going to be 300, and here is going to be 400. Okay, now it is a little bit difficult. That's why I would definitely encourage you to have a go at each of these questions. But once you've got the layout of the number of tickets, okay, and you've worked out the number of tickets from each of the particular groups, then it should be fairly straightforward to draw the lines in. So in terms of the seniors, well, we've agreed that the seniors is going to be 140, so that's up to there and then down again. Okay, in terms of the adults, what we've said is that's going to be 280. Well, that's all the way up there. Okay, so I'm going to go up to here. Okay, and I'm going to go along to about, oh, it's difficult to see in this light, but it's going to be along to about there. Okay, so there's a very wobbly line. Okay, and then the child ticket is going to be what we said, 380, so that's all the way up here again. Okay, so that's down like that, across to about there roughly, and then down again. Okay, So I hope that's all right for you. It's not the world's greatest diagram, but it'll give you some idea of the kind of diagram that you should be looking to achieve with your particular work. Okay, hope that's all right for you. This is 29 minutes into the video, so that's quite long enough to be doing maths, I think. We'll stop there, and then at the beginning of the next video, we'll start with question number 13. Please do add a comment below if you're not sure about anything. I'll always come back to you. I'll look forward to seeing you inside the next video.